Hey guys, let's discuss new problem from graph topic, and which is find the cycle in a find cycle in a directed graph. Okay, but using Kahn's algorithm or uh, using Kahn's algorithm BFS. Okay, so see here, very simple logic. The earlier video I have created on topology, this Kahn's algorithm only, where we work on the in degrees. Okay, so at the end all nodes in degree will become 0 and you print it okay, one by one when you process it. So here, if the cycle exists, then definitely the in degree of some few nodes will not be 0, right? And that is the core of this problem. Okay, solving the problem, very simple. Just run the means just solve it using the Kahn's algorithm. Okay, and then at the end just check if count is not equal to v, then then false, otherwise true. Okay, like that. So let me explain you what we have done there. Okay, in Kahn's algorithm. So see, you have given this adjacency list. Okay, and this is the graph, equivalent graph for that. So first you find in degree for all the nodes, vertices. What is in degree? In degree is how many nodes are coming inside the vertices. So for example, in degree of 0 is 2, in degree of 5 is 0, for 4 it is 0, for 3 it is 1, for 1 it is 2, for 2 it is 1, right? So you just find the in degrees. For 0 it is 2, for 1 it is 2, for 2 it is 1, for 3 it is 1, for 4 it is 0, for 5 it is 0. Now whose in degrees are zeros? Okay, just put that node into the queue. So this is my queue. Okay, so first I'll put 4 and 5. Now I'll pop one element from queue. So 4 will come first because it is FIFO, first in first out, and I'll print this 4. Okay, or print, or I'll store it in some array. Now whoever all the nodes which are connected to this 4, just reduce its in degree. So basically we are what we are doing, we are removing this graph, this vertices from graph. So definitely all the nodes which are connected to this graph, their in degree will also decremented by 1, right? Because that node doesn't exist, so they are not connected with that node. So who's connected with 4? 0 and 1, right? So 0's in degree will become 1, it's 1's also 1. Okay, it's time for 5. Check if any other nodes in degree become 0. No. So now it's time for 5. So 5, just put that 5 in the resultant array. Okay, and who is connected with 5? 0 and 2. So reduce their in degrees. Okay, now 0's in degree becomes 0. So 0 I'll put that in the queue, and 2 also. Okay, now next number is for 0. So 0 I will print. Okay, and I'll check who's connected with 0. Nobody. Now it's time for 2. So I'll check who's connected with 2. So 3. Okay, so I'll put 3 in the queue, and then I'll poll 3 also, and then we'll print it. And who's connected with 3? 1. So I'll put 1 also in the queue. Who's connected with 1? Nobody. So 1 is the answer. Okay, 3's in degree became 0 here, and then 1 also 0. Now if there is any cycle exist, let's say, okay, so this one is coming here, and let's say this 1 is going to 4, then in that case you will never get here 0. Okay, and you will just once all the nodes are completed using that for loop, at the end you will, this size of this array will not be equal to vertex. Okay, so then you can say, okay, cycle exists in the graph. So that is the crux. So if the processed nodes is equal to v, then no cycle. If it is less than v, then cycle exists. Okay, so what you will do, this is the I explained in the earlier video. Okay, this is the ditto same explanation, but let's see once again. You will create one in degree array. You will add all vertices in degree into that array. Okay, then you will create one queue, and all the vertices whose in degree is 0, you will add that into the queue. Now initially count is 0, and you will run one while loop, because this is BFS. Okay, we will use queue here, and then as we have added all the vertices whose in degrees is 0, we have added that in a queue. So you just take one by one element from a queue. Okay, do count plus plus, and check all its neighbor and reduce its in degree. Okay, and if it becomes 0, then add that into the queue, and continue this process. Okay, for this complete v vertices, and then at the end just check, just compare count and v. If it is not equal, then cycle exists, otherwise no cycle exists. So that's it. Thank you.